not in B. So this portion will be A minus B, right? Agree? Then we have A cross B. This is called Cartesian product of A and B, right? So what is it? It is basically the pairs such that A belongs to A and B belongs to B, right? Okay. So we can then see some examples. Suppose we have A equals some 1, 2, 3, 4 and our B is so what will be A union B? What is A?
1, 2, 3, 4, 8.
1, 2, 3, 4, 8. 1, 2, 8, 10.
8 and
1, 2, 3, 4, 8, 10.
This one, right? What is
Yes,
A?
ma'am.
What
One,
is A
two.
intersection B?
1 and 2.
1 and 2, ma'am.
1 and 2.
What is A minus B?
3, 4.
4 and 10 and then it's only 1.
4.
Only 4.
3, 4.
3 and 4.
3 and
Okay. So this is how we can introduce the operation, set operations. These are called the set operation, right? Then we have the Cartesian product, and using the Cartesian product, we define what a relation is, right? So what a relation is? Anyone? What a relation? What was the definition of relation?
Subset of the Cartesian product.
Correct. So R is a subset of A cross B is called relation from A to B, right? Right? This is a relation from A to B. Now we have classifications of relation. So we have some type of relation. So what are the types? First,
Symmetry.
Identity.
Reflexive, symmetry, and transitive.
right? So these are the 5 types of relation. So what a reflexive relation is? If R contains all the pairs A comma A such that A belongs to A, then this will be called a reflexive relation, right? What a symmetric relation is? If A comma B belongs to R, it will imply B comma A belongs to R, right? So whenever we will conclude something about symmetric relationship, we will first check whether A comma B is there or not. If A comma B is there, then only we will check for B comma A. But if A comma B is not there for any such AB, then this is not our concern, right? In that case, the relation will be automatically symmetric. What was the transitive relation? If A comma B and B comma C is in R, it will imply that A comma C also is in R, right? What a equivalence relation is? Reflexive plus symmetric plus transitive. And what was the identity relation? It was exactly the set A comma A such that A belongs to A. These were the definition of this 5 type of relations, right? Now, if I check example, so if I have A equals easy set, let us take the easy set 1, 2, 3. So what about this relation?
Madam, identity.
Reflexive and identity.
Reflective, both.
Yeah, that means it is basically identity, reflexive. What about symmetry
Yeah, symmetry.
and transitivity?
Yes, transitive.
So it is symmetry, it is transitive. That means it is an equivalence relation, right?
Correct.
Identity relations are equivalence relation.
Ma'am, this is how is this transitive? Because 1, 2, 2, 3, then 1, 3 will be there, right? That's the.
Yes, but here we don't have any ABBC pattern, right?
Oh, even if it is not there, we should consider that as a
Yes,
transitive.
yes. Like if there is some ABBC and if you can find some AC is not present in the set, then you can conclude it is not transitive. Okay.
Okay.
But if there is no ABBC pattern in the set, it will be automatically transitive. Okay.
Okay. Right. Thank you.
Mom,
Yes.
what is that IRST, mom?
Which lemma?
This one, after R1 equal to 1, 1, 2, 2, 3, 3, you wrote IRST, no, mom, that one.
Yeah, I'm just taking this one. Then suppose some 1, 2, 3. Okay. What about this?
Reflexive only.
Okay.
Reflexive, transitive.
Okay.
Reflexive, not symmetric, not transitive.
Why not transitive?
It is transitive. 1, 2, 2, 3 is there. 1, 3 is transitive.
Transitive. It is transitive.
No, it's transitive and reflexive.
Yeah.
Reflexive
Whenever
and
we are
transitive.
saying it is not transitive, that means we should have an example. If we cannot find any example, that means it will be transitive, right? So, whoever said it is not transitive, do you have any example?
No, mom.
Okay. So
No, mom, it is transitive. It is transitive. I didn't see that 2, 3 is there, mom.
Yeah. So we can pick any pair like 1, 1 and 1, 2. Then we need 1, 2. So 1, 2 is there. Similarly, we can pick any pair. So this will be reflexive and transitive, right? Okay. So R3, if I take some 1, 1.
If you take that logic, then this identity also is there, right? Because there is no 1, 1, 2, 2, 3, 3. So since it is not there, I can apply the same logic saying that it is identity relation because there is
No, identity relation is exactly this set. Like identity relation is unique. Okay.
Yeah, I know that. I know that the identity relation is always the same number 1, 1, 2, 2, 3, 3.
Yes.
But if you are, can't we apply the same logic as you explained for symmetric and transitive? That if we cannot prove that there is no identity, then we can consider that an identity, right? I don't know. I'm just trying to intuitively understand if we can apply a certain rule to one part of the equation, then we should be applying equivalently to the identity also. So in R2, I can always argue that it is also identity because there is no in R3, right?
The second example is R2.
Yeah, R2. So 1, 1, 2, 2, 3, 3. So it's identity, right? It's not.
No.
Sorry, no 1, 2, 2, 1, 1, 2, 2, 3, 1, 3. If I take that.
1, 2.
Oh, you have a full. Okay. 1. But it's identity. Okay.
Identity means only those 3.
Only those. Okay. Understood. Right.
If there is any extra element in the set.
Yeah. Then it's not identity.
Yes.
Okay.
Yes. So identity, if as per the definition, I wrote.
Yeah. I got
identity is exactly that set, right?
Right.
Yeah. Anything
Sorry.
else? Any other doubt? No, it's fine. Your voice is breaking. Yes.
For R1 example, R1 equals to 1, 1, 2, 3.
Your voice
It
is
is symmetric. Now clear, ma'am?
Yeah, now it's okay.
Ma'am, for the previous example, R1 equals to 1, 1, 2, 2, and 3, 3.
Hmm.
How is this symmetric? I'm little confused about this
Okay.
symmetricity.
So symmetry means if you have AB, then you should have BA in the set. Okay. So do you have AB here?
No, ma'am.
So it will be automatically symmetric. That means if you have AB, then you have to check for BA. But if you don't have any AB in the set will automatically be symmetric. Okay.
Okay, ma'am. Thank you.
Yeah.
So
Yeah.
by default, every relation is symmetric and transitive unless proved it's not.
Yes.
Okay.
Unless you can find an example which is contradicting
Which
the
is
definition.
contradicting the definition, it
Yeah.
is always transitive and symmetric.
Yes. Yes. Correct.
And ma'am, for identity relation, if there are other elements, like for an R2, there is 1, 2, 2, 3, and 1, 3.
Hmm.
So you can say it's identity relation.
No, identity relation is the unique one. Like only those element will be there. No
Okay.
extra
Okay.
element will be there. Okay.
Okay. So it is reflexive but not identity.
Yeah. So basically, identity relations are a subset of reflexive relation. Like
Yes.
a relation which is identity will be reflexive, but a relation which is reflexive may not be identity.
Ah, yes, yes, yes. Okay.
Yeah.
Ma'am, for in R2,
Hmm.
symmetry, we need to check for each and every element, isn't
Yes.
it?
Yes. Whenever
Okay, got it.
you can find any AB, you have to look for the BA. If the BA is not there for any AB present in the set, if the BA is not there, then it will not be symmetry. That means you have an example which is contradicting the definition, right?
Okay, when I have to look for symmetry, I need to check each and every element in this
Yes,
set.
correct. Okay. Yeah. So what about R3?
Reflexive and symmetric.
Okay, first start with reflexivity.
Yeah. So reflexive, symmetric.
It's not reflexive, but I think it's symmetric and I think it's transitive.
What about others?
It's not
Yeah.
It's
Not
reflexive.
symmetric.
I think it's
Okay,
three is not there.
Yeah, 3 is not there.
Not there, so it's not reflexive.
So not reflexive.
Then it's 1, 3, 3, 1 is there.
So it is symmetry.
Symmetric, and there is no 1, 1. It's a transitive because 1, 1, 3, 3, 1, and 1, 1 is there.
not transitive. 1, 3 is not.
3, 3 is not there, ma'am. So it's
Correct.
not transitive.
Correct. So
Okay.
the thing is, you can take it as 1, 3, 3, 1. Also, you can take it as 3, 1, 1, 3, right? So if you take as 1, 3, 3, 1, then you need 1, 1. 1, 1
Yeah,
is
1.
present in the set.
Correct.
But if you take 3, 1, 1, 3, then you need 3, 3, right?
Oh, both are needed to be
Yes.
transitive.
Yes.
Okay.
Any such pattern, for any such pattern in the set.
Okay.
So it is
So
also following the pattern.
in one,
right?
if you take 1, 3, it is matching because 1, 1 is there. That's what I initially understood, that it's 1, 1 is there, so it's transitive. But if you take
can,
3, 3, 1, it's other
Yes.
way out.
Yes. 3, 1, then 1, 3. Then 3, 3 should be there to be transitive. But 3, 3 is not there in the set. That means the set will not be transitive, right?
So you have to apply for every element like that
Yes.
to make sure
Yes.
that it's a transitive.
For any pattern, any
Yeah,
such pattern present in the set.
Sure.
So if you can find any single example in such pattern which is not following the definition, that means simply conclude it's not
Right.
following the.
So in that case, it always has, the pattern has to be A comma B, because if you have a comma A, then there's no pattern there.
Yeah. So A comma A means obviously it will be
Yeah,
automatically
it doesn't.
there.
Yeah.
It is not making any sense.
Right.
Yeah. Okay. So lastly, 1, 1. Okay, so what about it?
Ma'am, the second one is 2, 3 or 1, 3?
2, 3.
Okay.
Suppose 2, 1 is also there. 1, 2 is also.
It's not symmetry.
Yes. What about transitivity? It is clearly not reflexive, right? Right?
No, it's not transitive also.
Yeah.
Why?
If I say, for example, take 2, 3, then there is no 3, 2, and there is no 2, 2.
Okay. So we need 2, 2, but there is no 2.
Yeah.
So it's not reflexive. It's
No
not
transitive.
Okay.
So there is not equivalent also.
Yeah.
Direct.
Yeah. Direct.
Right.
Okay. So these are the some example. Is there any other doubt in this reflexive, symmetric, transitive things? No? Okay, fine. Then we can move to functions, right? So what are functions? What is the definition of function?
Ma'am, sorry to interrupt you. Just to refer back to the R4, the last one, R4. Now, if you apply that, if you don't see a pattern, we can always go back and say that it's reflexive or something like that, right?
Yes. No,
So,
for symmetry and transitive, we need a pattern. For
okay.
reflexive, all the same pair should be there.
So if only that is if it is not there, then it's only applicable for reflexive.
Yes.
That if you don't see that, then
yes. If there is any A present in the mother set A such that AA is not there in the set, that means this is not reflexive.
Okay. That's how this rule is applicable only for reflexive only, not for other things.
Yes. Okay. So reflexive we can say only if AA such that A belongs to A, this set, that means particularly the identity relation is subset of that relation. Only then we can say the relation is reflexive. Correct.
But you also mentioned about symmetry also, no? When you don't see AB.
For symmetry, it's something different. If there is AB, then you will check for BA. But if there is no such AB, then it will be automatically.
Automatic symmetry. Okay.
Yeah. Same for transitive.
Here we saw AB in the R4, but there is no BA, so there is not reflexive.
Yes, correct.
Symmetric. Yeah, thanks, ma'am. Thank you.
For transitivity also, it will work in the similar way, right? If there is then we will check for.
Sure.
Okay. Anything else? Any other doubt? Okay. So what a function is?
Actually, it is counterintuitive. That's why it's always a confusion.
Yeah. Yes.
It is not normally the logic doesn't follow that actually. Right. Sorry.
Okay. So the basic thing is what logic you should keep in your mind is if you can find an example which is contradicting the definition, that means it's not the thing. But if there is no example, that means obviously it's following the definition, right? So that means it's fine. Okay. Yeah. So what a function is? I don't need the proper definition. If you can even express what was the meaning of a function, then also it's fine.
For some inputs, it will give an output.
For every input, unique output.
Correct. So that word every and unique is matters, right? So if yes. Okay. So a relation, if I have a relation from A to B, this relation will called a function. If input from A, that means domain of the function, has a unique output. Yeah. output or image, right? Image in B. So then we will call the function. So the set A is called the domain of the function, and the set B is called the codomain of the function, right? And what is range of
Yes, ma'am.
function? Range is basically f of A. Right?
Possible output.
Yeah, that means collection of all outputs. So range is always a subset of codomain, right? In some case, the range can be equal to codomain, but typically the range is a subset of codomain, right? So if I just check the Venn diagram, is it a function?
No,
No, ma'am.
Why?
there is no output for this third one.
Because one element not, ma'am.
Correct. So this element has no image. So this is not a function. What about the second one?
Not a function, ma'am.
So
Not a
it is
function.
basically contradicting the word each element of A, right? And this is not a function. Why?
Unique
Because,
output, not a
Yeah. So what this element? No unique.
single input gives us multiple outputs.
Yeah. So this is not a function. What about this?
function.
This
It is
It's a
function.
function.
The function, right?
Yeah.
So then we have 1, 1 and onto function, right? So what a 1, 1 function is?
For each element in domain, there should be unique.
every
No.
every image have every image must have a pre-image.
Every image must have a
Must-
unique image, right?
Pre-image.
Every input has a unique one and only one output.
Yes, that means we know if f is a function, that means every input should have a unique output, right? But if we want to conclude it's a 1, 1, then every output should have a unique input, right? Agree?
Yes, ma'am.
Yes, ma'am.
Every output should be associated with a unique input, right? That means the reverse thing we will say, right? So for function, every input should have a unique output, and for 1, 1 function, obviously because it is function, so every input should have a unique output, but additionally every output also should be associated with a unique input, right? So if I just write it mathematically, then it means if f of x1 is equals to f of x2, it will imply x1 equals to x2, right? Or
Yes, ma'am.
else, yeah, or else another definition, contrapositively, we can say if x1 is not equals to x2, it will imply f of x1 is not equals to f of x2, right?
Yes, ma'am.
Then we have a horizontal line test and vertical line test, right? So what is the vertical line test?
It will tell if it is a graph is a function or not.
Yeah. That means whenever we have a function, what a graph of function is? Graph of wave is the set x comma fx, right?
Yes, ma'am.
That means if I take, this is suppose our domain and this is our codomain. So for any element present here, we can find the image here, right? Right? For any element in the domain, we can associate that element with the image in the codomain, right? That means in the y-axis. The y-axis is codomain here. Okay? So then if I take this point, that means this point, right? This point is x comma fx, correct? Right? So for any x present in the domain, similarly, we can find so many such f comma fx. Then we will join them and we will find a figure, right? That figure is called graph of a function, right? So what the vertical line test is, if I draw any vertical line on a figure, and if it cuts the graph at one point, then it is a function. If not, then it is not a function, right? So why is it so? Can anyone explain it? Why is it so?
If it cuts in more than one point, then that means it is not a function because it has two outputs for a unique image, for a unique pre-image.
Correct.
Correct.
So if I take this thing, so this is not a function because that vertical line will cut it at two different points, right? That means for this point x, this is our fx. This is also our fx. That means for that x, we can find two different images. But if f is a function, this is not possible, right? So vertical line test is saying that, right?
Fail.
Yeah. Now, what was the horizontal line test? Similarly,
Checking
if I,
function is 1, 1.
yeah, so we can check with the horizontal lines whether the function is 1, 1 or not. That means again we will draw horizontal lines over the graph. If it cuts the graph at one point, then it is 1, 1. Otherwise, it is not 1, 1. So if I take this line, suppose this is our f. This is clearly 1, 1, right? Any horizontal line will cut it at one point. But if I take a parabola, then it's not 1, 1 because any horizontal line you draw, it will cut the graph at two different. So these are the horizontal line and vertical line test.
So for the same y value, for a unique y value, you are having two x values, right?
Yeah.
That
means for this y, for this output y, we can find two different input. That means that output is not having a unique input. So it will be, it will not be 1, 1, right? Now what a 1-to function is? What a 1-to function is?
it is 1, 1, 1 and
Generally,
both,
ma'am, every generally codomain, so I think range of function we can say the function is on to.
Okay. Okay, you are saying what you are saying is correct. Okay. So first we can say simply the range will be equals to codomain. That means all the element in the codomain should have a pre-image, right? So mathematically we can express for any y belongs to the codomain B, there exists a x belongs to the domain A such that f of x equals to y. This is the mathematical expression, right? Right? That means if I want to prove a function as on-to function, so we will start with any y in our codomain. Then we have to check whether there is x present in the domain for which the functional value will be y. If it is correct, then the function will be on. Right? So if I take the function, suppose fx equals to x square minus 1 from r to r. Okay. Is this function 1, 1? So our domain and codomain both are real number here. Okay. So is it 1, 1?
No, ma'am.
No, ma'am.
What is the one line justification for this?
It doesn't pass horizontal line test.
Yeah. So quadratic equation means the parabola. Parabola means it will fail the horizontal line test. That means not 1, 1. Okay. Is it onto?
No, it is not.
Why?
Because the negative values won't have any pre-image. Negative values in the codomain.
Okay. So we can, how can we find the range then? Like, if I want to make it onto, so we have to find the range, right? And we have to restrict the codomain to range. Then it will be onto. So how can we find the range? So range means what I always say, if you want to find the range, so we have to check whether the function is like, you have to check the functional value at the boundary points, right? So the domain is a real number, right? Is there any issue with the domain?
No, ma'am.
Okay. And okay, so the domain is real number. Codomain is real number is fine, but we want to find the range. So if we can check the end behavior, right? So if x is tending to infinity, then what about fx?
Tends to infinity also.
Yeah. And also if x is tending to minus infinity, then fx will be tending to infinity again, right?
Yes, ma'am.
So it's a parabola in the downward direction. Sorry, upward direction, right? So this is a parabola. Now, if I have a parabola, we can find the vertex. What will be the vertex of the parabola?
Minus b by 2a.
Yeah, I will come to that. So, yeah, minus b by 2a, right? So, what is the exact point? What is the exact vertex here?
That's the minimum point.
Yeah. So, what is the vertex here? What is the minimum point here?
I think
Minus
0.
0, right?
0. Yeah. Minus infinity or plus infinity. Yeah, 0.
0. So, the minimum point?
But
Yes.
but it can be any other value on the y-axis, right? Because you are looking at minus infinity to plus infinity. The starting point can be 0. I mean, it can be 0, but it can be any other value also.
No, the starting point is not 0. The starting point, like if you are tending x to minus infinity, that is the starting point, which is something near infinity. So it is the figure, no? Starting point is somewhere here. Then it is coming to 0. Then it is again going to the upward direction.
Yeah.
So you have to find
you
the
can-
minimum and maximum value.
Ma'am, and we can go also through the formula minus b by 2a, I think.
Yes. So minus b
Of
by
these,
from that formula also we can find. So if I have the equation of the parabola in this form, then
Yeah.
the vertex is minus b by 2a, right? And what is b here? 0, right?
0. So it becomes 0.
Yeah. That means this point is the lowest point and the coordinate of x coordinate of the point is 0. So 0 is the lowest point. Okay.
Yes, ma'am.
Oh, I'm sorry. Sorry. This is the x coordinate, right? Oh, we want to find the lowest. We want to find the range. That means we have to find the lowest point in the codomain, not domain, right? So
And lowest
0 is the
minus
x
1.
coordinate,
Minus 1.
right? So we have to find the lowest point in y-axis. That means we have to find f of 0. F of 0 will be the minimum, right?
Yes, ma'am.
Which is minus 1. So the range will be then, what is the range then?
Minus 1 to infinity.
Minus 1 to infinity, right? So we know that whenever we are finding the vertex is actually minima. That means at that point we can find the minimum value, but the range is the minimum value, right? Like the lower bound of the range is the minimum value. So if I just calculate the y-axis of the vertex, it will be the lower bound of the range, right? So the range will be -1 to infinity here. Any doubt?
Yeah, the graph will start from below the x-axis, right? Now, in that case.
Yes.
Yeah.
This is our vertex. This is 0, -1. Okay.
Ma'am, when you say R to R, it is always domain to range, right?
It is
Not
domain to codomain. It is
Codomain.
domain to codomain. Okay. And we wanted to find the range. So range is sometimes the range can be equals to the codomain, but typically it's a subset of the codomain, right?
Yes.
So if I take R as the codomain, then this function will not be onto, because if I take the -2 in, this is a member of R, right? But there is no pre-image for that -2, right?
Okay.
Is there any point for which the functional value can be -2? That means, is there, if, like, we can say if there exists x such that f of x equals to -2, then what we will find? What is f of x? X square -1, right?
Yes.
-2. So this will be x square equals to -1. Is it possible?
No.
No, ma'am.
A square term can never be, if it is real, then a square of a real number can never be negative. Sorry. That means for -2, we don't have any pre-image, right? That means obviously the function will not be onto from R to R. But what if I take the function from R to -1 to infinity? Then it will be onto, right?
Yes.
This is the range. So if I take any point from the range, any point, even we can include the -1, right? So if I take any point from the codomain now, the new codomain, then we can find a image, right? Sorry, pre-image for that point, right?
Yes.
So this function is now on,
Okay.
but this function is not on. Okay. Any doubt?
No, ma'am.
Okay. So one note we can use is composition of two 1 function is 1 1. Okay. Of 2 1 1 function is 1 1. Again, composition of 2 onto function is onto. Okay. That means if you have 2 1 1 function or 2 1 2 function, if you just do the composition of these two functions, the composite function will be 1 1 and on respectively. Okay. So one more example we can say, if I take f(x) equals to logarithmic of logarithmic x, then what is the domain of this function?
Logarithmic function domain is always 0 to infinity, right?
But it is ln of ln x.
Oh, okay.
What will be the domain of this function?
So ln of x is inverse of ln of x, right?
No. Inverse of ln is always, we will go to exponential.
Exponential, but 2 times log 2 times
ln of
logarithm.
x, the first inside the inner function's range is minus infinity to infinity.
Okay, so we
Right.
will start with this portion, right? So
Uh.
know that the range, the domain of logarithmic is 0 to infinity, right?
Range is real number.
Domain is 0 to infinity,
0
right?
to infinity. Okay.
So that means this ln x should be greater than 0.
Yes.
Otherwise, we can't define it, right?
Oh,
Right?
yes. Yes.
Now, if ln x is greater than 0, we can apply e, right? Exponential function over here, right? So e power ln x is greater than e power 0, right?
Okay.
So then,
n greater than 0. 1. Ah, right. 1. Okay. Okay.
that means x will be in this set. So this will be the domain, right?
Can you explain, ma'am? I didn't understand.
Sure.
So ln of x domain, I understand it's 0 to infinity, and
Hence,
so ln of x is greater
will
than
be-
0.
Yes.
Greater than
Now,
0.
if I apply e, that means our exponential function, the e power ln of x will be greater than e power 0, right? We are applying e both the side. Nothing.
Correct.
So e power ln of x will be x.
Correct.
And e power 0 will be 1.
Is 1. Okay.
X is greater than
Greater
1.
than 1. Okay.
So that means we can say when x is greater than 1, then we can go in this way also, right? When x is greater than 1, it will imply this line and it will imply this line, right? That means when x is greater than 1, then for any x which is greater than 1, we can define the function f. So this will be the domain of the function. Okay?
Right.
Okay. So
X is 1. If you include the 1, the inner function will give you 0. Then the outer function will become ln of 0.
yeah, so ln of 0 is minus infinity, right? Like tending to minus infinity. Ln of 0 is not defined, right?
That is why I'm asking, how do you include 1?
We are not including 1. Open bracket, no?
Oh, open bracket. That's okay.
Yeah.
I thought it was a closed bracket.
No,
Okay.
no. We are not including 1. We are excluding 1 here. This is an open bracket.
I mean, the first instance, the ln of n greater than 0. But our domain is 0 to infinity, right now.
Yeah, greater than 0 means belongs to 0 to infinity, right?
Okay, so 0 is not included in that.
No. Strictly greater than 0.
Strictly greater than 0. Okay.
0 is not included.
Okay.
Any doubt? Anything else? Okay. So then we can come to 1, 1. Is it 1, 1?
Yes, ma'am.
Why? What is the reason? What is the reason?
The graph has just like shifted to the right, like it's still the same shape.
No, it is not a shift. Shiftment is like if you add a constant with some function, then you can say it is a shifted function.
Okay.
We can use this above note, right? Composition of two 1, 1 function is a 1, 1 function. So you know that logarithmic function is 1, 1, right? So here we are composing logarithmic function twice, right?
Yes, ma'am. I understood.
Yeah. So logarithmic function is 1, 1. Hence, logarithmic of logarithmic function is basically composition of logarithmic function twice. That means it will be 1, 1. Any doubt? Okay. What will be range? What is the range?
Ma'am, real numbers?
Yes, correct. Range is real numbers. So when we will go towards infinity, ln of infinity is infinity, so the function will be tending to infinity. If we check towards 1, so ln of 1 will be going towards 0, and then f of 1 will be going towards minus infinity. That means minus infinity to plus infinity. So basically R, whole real line. Okay. Any doubt? So our domain is 1 to infinity. Our function is 1, 1, and our range is real number. That means the function from 1 to infinity to real number is on to function, right? Right? Any doubt here in this example? No. Okay. Now we can come to bijective function. What a bijective function is? If it is injective and surjective, that means 1, 1 and on to.
Ma'am, sorry, you said the previous example is on to.
Yeah. So the range is R. So if I take the function from 1 infinity to R, range is equals to codomain. That
Okay,
means the function is on to, right?
Yes, ma'am.
So it is 1, 1 and on to. Hence we can say it is a bijective function.
Yes, ma'am. I didn't know that the codomain was real numbers.
Yeah.
Now I understand.
Codomain is real number, right? Okay. Okay. So bijective function means 1, 1 and on to. So sometimes we can call the bijective function as invertible function, right? So if a function is invertible, that means there exists another function. We can denote it as f inverse, such that f compose f inverse of x equals f inverse compose f of x is equals to x for all x present in the domain. For all x. So this is the definition of inverse function. That means if I have a function, we can also find the inverse function of that function using this definition. Okay. So if I see an example, for example, if I have f of x squared from R to 0 to infinity. Okay. So first thing is this function invertible from this domain to this codomain?
It cannot be, right? If you reverse it, if you apply 0 and to infinity as a domain, you will never get a real line, right?
What?
No, what I'm saying is here your f of x is from real to 0 to infinity.
Yes.
Now, when you are reversing, your domain will become 0 to infinity. Your codomain will become a real line, right?
So what I just asked, is it invertible or not? You're saying it is?
It is not. I mean, that's what I'm saying.
Yeah, it is not invertible. Why?
Yeah, it is not invertible. Because when you apply 0 to infinity as a domain, you will never get a real line.
Or more simply, what we can say?
Oh, it's
not a 1, 1, right?
Yeah, not 1, 1, because it's a parabola, right?
Yeah. But if I take the function from 0 to infinity to 0 to infinity, then
that means you are restricting the domain to 0 to infinity.
Yeah.
Right.
Then this half of the parabola.
Instead of real number, line,
I'm
you are
restricting
only
the
restricting
domain. Now is it invertible?
Yeah.
So it is 1, 1 and it is on. So it is invertible, right?
Yeah.
That means the inverse exists. So what will be the f inverse?
Square root of x.
Y square.
Square root of x.
Square root, yeah.
Correct. The square root of x. So how can we calculate? Using this definition. So we know f of x equals to x square. So f inverse of x is x, right?
X on the root. Yeah.
From this definition, we have this, right? Now what? What is f of f inverse x? This equals to x, right? Applying the definition of f, right?
Yeah.
So f inverse of x will be x. Fine. That means this is the inverse. Okay. That is how, using this definition, you can always find the inverse of some function. Okay.
Ma'am, simpler way is, one second. Simpler way is just replace x with y. So, for example, if you,
Yeah,
f of x is equal to x square, so I'm assuming f of x is y. So let me write y is equal to x square in the first step.
Yeah.
Okay. Now
Then you have to
replace
find the
x.
value
Yeah.
of
Replace x with y and y. So if you want to calculate y, then it will be x root of x.
Yeah. Yes. So here we are just taking f of x equals to y. Okay. So using these things, what will be the inverse of this function? Ln of x.
So y is equal to e to the power of ln of, okay.
This. Then
So you replace x with y and y with x. Ln of y. So if you have to, so this will become
and we have to find the value of y from here, right?
correct. So first the one ln will go to the left. So that will become inverse of e to the power of x, right?
Correct.
E to the power of x is equal to ln of y. Now to make y, then again you need to bring this ln to the left. So that means e to the power of x is equal to y.
So that means e power x is the inverse of this function. Any doubt? Okay. And maybe we start with quadratic equations. So this is a quadratic equation. So this is a general form of a quadratic equation, right? So if I have a quadratic equation, we know how to find the root of the quadratic equation. We have a one-step formula for that, right? X equals to minus b plus minus root over b square minus 4ac by 2a, right? This is the formula to find the value or the root of a quadratic equation, right? And this term b square minus 4 is called the discriminant of the function. Now, depending upon the discriminant, we know that we can classify the function in three different ways. First, it can be greater than 0, it can be less than 0, it can be equal. These are the all possibilities, right? These are the possibilities we have. So it can be, the discriminant can be greater than 0, the discriminant can be less than 0, or it can be equals to 0. So if the discriminant is greater than 0, then we have distinct root. That means we can find two different roots. If it is less than 0, that means no real root. If it is equals to 0, that means repeated, right?
Yeah.
So depending upon the discriminant, we can find the number of roots. So a root is what? As a basically x-intercept of the graph of the function, right? The root of f is nothing but x-intercept. Right? Right?
Yes, yes, ma'am.
Yeah. Okay. So we know that if I have a general equation like that, so we can basically conclude that it is a parabola. It is a figure. The graph will look like a parabola. And it can be a parabola in the upward direction. It can be a parabola in the downward direction, depending upon the constant a, right? So if a is greater than 0, then we will find a parabola in the upward direction. That means like that. If a is less than 0, then we will find a parabola in the downward direction. That means like that, right? So these two type of parabolas are there. Now, if our discriminant is equals to 0, that means repeated roots are there. That means we will find this type of picture or this type of picture. This is our x-axis. Agree?
That means both roots are the same number.
Yeah.
Repeated roots.
Yeah. So discriminant in 0 means both the roots will be same. So we
Yeah,
will
it's
find a U type of shape at the root, right?
So it's touching exactly at one point on the x-axis. Right?
Yeah. Yes. Okay. So if it is greater than 0, then the figure will look like this or this, right? So
Yeah.
two x-intercept means two different roots. What if it is less than 0? Then we will find
Imaginary.
right. That
Yeah.
means it will not cut the x-axis. Simply say. So these three types of figures we have. Now, if I have a parabola, this point is called the vertex of the parabola. So, and this line is called the axis of symmetry. That means with respect to that line, we have the symmetric figure, both the side, right? So these are the things. Now, the vertex is, if a is greater than 0, then Vx means x coordinate of the vertex is the minima, right? Minima. And f of Vx means y coordinate of the vertex, it is the minimum value.
Minimum value.
And if a is less than 0, then what is Vx?
Maximum value. Maxima.
Maxima. And if f of Vx equals to y, Vy is the maximum value, right? Maximum value of the parabola. So these are the things we have. And the last things is we have a different form for parabola. That means y minus h equals to a into x minus k whole square. This is a different form for parabola. We can also write it as y equals h plus a into x minus k. If you have a parabola in this form, that means for this type of parabola, directly we can conclude the vertex is h comma k. Okay. So from this form, we can go to the general form of the parabola. Also, from the general form, we can come to this form, right? That means we know that we can shift from one form to another form. So this flexibility we have. And if I have this in this form, the equation of the parabola, then hk will be the vertex. So we don't need to calculate with the minus b by 2a thing. This will be automatically the vertex. And if the parabola in this form, ax squared plus bx plus c equals 0. So the Vx is basically minus b by 2a, right? And the Vy is f of Vx. That means f of minus b by 2a.
Ma'am, in this case, the earlier equation, h comma k is a vertex. So k is automatically, we don't have to calculate, k will become the maxima or minima depending on the a value of a, whether it is positive or negative, right? In the
What?
above equation. in the
Uh-huh.
equation y is equal to k plus a into x minus h, h minus k whole square, that equation, you said vertex is h comma k.
Yeah.
So in that case, k will automatically become a minimum or maximum value depending on the A's polarity, which is whether
Yes.
A is minus or plus.
Yes.
Is
Correct.
that right? So straight,
Yes.
if in the exam, if there's a problem given with this equation, we
Hmm.
can straight away say that the maxima or minima will be equal to k.
No, maxima or minima is h.
Minimum value, sorry.
Yeah, maximum
Maximum
value is exactly k. Yes.
k, and it will be maximum or minimum based on the A's
A.
polarity.
Yeah. So if A
Yes.
is positive, then you will find the minimum or minimum value. And
K.
if A is negative, then maxima or maximum value.
The k value will be the maximum.
Maximum value. Yeah.
Okay, right. Thank you.
That h is the minus b by 2a.
Yeah. H is actually minus, we can also calculate it, right? So we have y equals to k plus a into, we can break it. So it will be x square minus 2xh plus a square, right? Then it will be a x square minus 2ahx plus a square x plus k. Square a plus k, right? So we can rewrite it as our b, it as our c, and a is by itself. So if our b is minus 2ah and c is h square a plus k, if I take this in this form, so this equation can be again written as a x square plus bx plus c, right?
Yes, ma'am.
And the vertex will be minus b by
2a. So
now
it
we
is
can
also
put the value. So it will be 2ah by 2a. That means h.
minus, okay. Minus goes away, right?
Yeah. Okay.
Yeah.
So that means we can come from this form to that form. So we can go from general to intercept, intercept to general. If I found the intercept form, then hk will be the vertex directly. If I have that general form, we have to calculate with the definition minus b by 2a. Okay.
So assuming a problem is given where the equation is given in the form above, in the y is equal to k plus in this form k plus a into x minus h whole square, and we are asked to find the root. So straight away we have to say h is equal to minus b by 2a, and solve that equation to find the root of that equation.
Okay, so if you want to find the root, so you have to equate y with 0, then you have to calculate the value of x. Root and vertex is not always same, right?
Oh, okay, right.
Vertex
You're
can
right.
be root,
Vertex
it
can
cannot
be,
root.
correct. It can be or cannot be, right? You're right.
Yeah.
So you should simply y is equal to 0 will solve the problem.
Yeah.
Okay.
Yeah. Simply you have to take y equals to 0
Right.
then you have to directly, if it is in that form, so you can directly compute. Otherwise, if it is in the general form, you can use that squaring the sum.
Sure, right.
Or the Sridhar Acharya rule, minus b plus minus root over d, that thing, right?
Yeah.
Okay. So if I have the parabola y by 2 minus 10 equals to okay. So what is the minimum value of this? First, what is the vertex? What is the vertex of this parabola?
X square.
It involves two variables.
Yeah.
X square minus 10. Y is equal to x square. Y is equal to x square minus 10. 2x square minus 20. Y is equal to 2x square minus 20.
Plus 20, right?
Yeah, sorry, plus 20. So now minus a by 2 minus b by 2a. So minus b is 0.
We don't need to calculate.
Yeah,
minus
calculate. So
by
it,
two.
the vertex will become 0. So if you
H
make
is
0
here,
in,
right?
then the maximum y is equal to 20.
Yeah. So we need not to calculate it directly.
Yeah.
H is 0 because x square means x minus 0 square, right?
Correct.
And k is 20.
20. So your vertex is 0, 20.
So the minima is 0 and minimum value is, right?
20.
Okay. Now we can come to polynomial of degree n, right? So we know that typically we can express it as a naught sum a1 x plus up to sum a n x power n. So where n is not equals to 0, then the maximum degree of the polynomial is n. So this is called a polynomial of degree n, where this n things 1, n, 2, these are the exponent or power of the polynomial or the monomials, and that ai, that means a naught, a1, an, these are coefficient of that term, right? So the coefficient of highest degree term will always be not equals to 0. Okay. So n is not equals to 0 means we can say that the polynomial px is a polynomial of degree n. Okay. Now for a polynomial of degree n, we can have at most n roots, right? That we know, right? The degree is the maximum number of roots, right?
Yes.
So these roots can be repeated. This can be separate, right? So that means we can consider alpha 1, alpha 2, some alpha r to be roots where r is less equals to n with multiplicity I1, I2, IR. That means the repetition of alpha 1 is I1, the repetition of alpha 2 is I2. Okay. In that way, we will go up to R. That means the repetition of the root alpha R is IR. Okay. And this R can be less equals to N. So if it is equals to N means N distinct root. But also there may not be, all the roots may not be distinct, right? There may be some repeated roots. So we are considering all the case in this general way, right? So if alpha 1, alpha 2, alpha r are roots of the polynomial with multiplicities I1, I2, IR, then we can write the polynomial as x minus alpha 1, I1 into x minus alpha 2, I2, x minus alpha n, in this way, right? Any problem here? This we know, right? This we already know, right?
Yeah.
So if I have the,
X equal to x will become x alpha 1 can become one of the root of x. Similarly, alpha 2 can become one of the root of x. But
Yeah.
this multiplicity I1, I2, I didn't get that part.
Multiplicity
Yes.
means number of time the
Repeat.
root is repeating.
Repeating. Okay.
Yeah. So these all are I1, I2, IR are natural numbers. Okay.
Correct.
So that means then if alpha 1 multiplicity I1 means there are the alpha 1 is a root I1 times.
Yes.
Okay. So now if I have a polynomial, that means this will have root, and if it is having some root, so we can factorize it and we can write it as in this form, right? With respect to their roots and its multiplicity. Now we can draw the graph of a polynomial. So if we have even power, the exponential is even, means at that point we will find this type of U type of figure, right? If the power is odd, greater than 1, then we know that this is the behavior of the graph at that point, right? And if it is 1, then it will simply cross like that. These things are known, right? So then we know that if I calculate first the end behavior, do it. Second is like if I calculate the roots with multiplicity. If I calculate these two things, then from any polynomial, we can draw the graph of a polynomial, right? Using this thing and the end behavior, right?
Yes, ma'am.
Yeah. So we can maybe see an example. If I have some fx equals to x squared, x minus 1 cube, x plus 2 power 5. So first we want to draw the graph of this thing. So what is the end behavior?
So the odd multiplicity, so it will become like a cube graph. Sorry, 5, 6, 7, 8, 9, 10. So it's an even multiplicity, right? 10.
Yeah.
Sum of the roots, 5 plus 3
What
plus
is the
2.
degree?
Degree is 10.
10.
So if x is tends to infinity, then f
10 is even, so it's a parabola. So x infinity will become y is equal to infinity, right? And minus infinity also minus infinity. Oh,
minus
sorry, infinity. No, sorry, infinity.
Yeah. Now we have to check the roots with multiplicity. What is the first root?
0, 1, and 2.
X
0,
equal
1 and
2.
0,
Minus
1
2. Minus 2.
Oh,
with
sorry, minus 2.
multiplicity. 0 with
2,
1 with
3,
3.
minus 2
and
with
5.
5.
So first we will note the roots. So these are the roots, right?
2. Yeah, 2, 3,
0,
5.
1, minus 2. Now the end behavior are like when x is tending to infinity, the graph is tending to infinity. That means upward direction. When x is tending to minus infinity, the graph is tending to infinity. That means again upward direction. At the point minus 2, we have odd. That means this type of figure, right?
Yes.
This type of figure.
And
At
parabola that cuts from minus 2 to 1.
This, right? At 0, we have even. That means this type of figure we will find, right? Agree?
Yeah, even is parabola, right?
Yeah. Again, at 1, it is odd and greater than 1 means this. Now we will join the end. So this will be the graph of the function, right? So how many number of turning points are there?
3.
Okay. So this is the first turning point, this is the second turning point, this is the third turning point, right? So number of turning points is 3.
Madam, 1 second, I'm trying to analyze the graph. So at the 0.
I can draw the graph more. It is going like that. Then near 0, it is coming like that. It's Okay. Is it fine? Any doubt?
So at -2, since it is odd degree,
Because it is odd, so we will find this type of figure, right?
yeah, that is what we have drawn. And at 0, we have
Even.
second square degree, so it should be like parabola.
Yeah, like that.
And again at 1, okay, got it. At 1, it's
So this,
odd degree. So
this,
yeah,
and this.
yes, yeah, perfect,
Right?
perfect. Yeah.
So if, ma'am, if you follow this approach, first you have to draw the end behaviors.
Yeah.
Then you have to take each one of this 0, 1, -2, which are the intercept points, and draw the behavior of a even or odd behavior of the multiplicity.
Yes.
And then connect all the broken lines into a single graph. Is that right?
Yes, yes.
Okay.
So this is the easiest way you can just draw the right graph. Right?
So in the exam, they may give a equation and give a set of graphs, and I didn't say that identify the right graph. Is that
Yeah.
right?
Yeah, you may have this type of question in the exam.
Okay.
So from the graph, from the equation, we can draw the graph, and we can obviously comment about the turning point, the maximum degree, right? But if I have a random graph, then also we can comment about all the things like maximum point, maximum turning point, maximum degree. Also, we can construct the equation of the graph after seeing the picture, right? And we know how to do it. So just to recall, suppose this is our graph, okay? This is -3, 1, and these are origin. So how many number of turning points are there?
3.
How many number of turning points are there?
3, ma'am.
Yeah. So this one is first turning point, this one is second, and this one is third turning point, right? So 3 turning points are there. What is the minimum possible degree of the graph?
Equal to the turning point, right, ma'am?
See, 9? 9 is the maximum.
Is also 3, I guess.
What is the minimum possible degree?
Oh, n-1, right?
1.
So 4 degree 4.
1.
Anything else?
4. I think turning points +1.
Okay. So see, the maximum possible possible number of turning point is equals to n-1, where n is the degree of the okay. But there is no relation with n and exact number of turning points. So here we have exact number of turning points is 3. From this we cannot conclude about the degree. For degree we have to look at the graph. So degree means we have to check the multiplicities of root, right? So you just check at the roots and just conclude their multiplicity just seeing the graph. So what are the roots?
X plus 3 square, right? Because it's a parabola.
10.
X plus 3 whole square. Then
7.
So,
x minus 1 whole cube,
minus
x minus 1 whole cube. Then another root is at 5, which is again
X minus 5
x minus 5 whole cube, right?
whole cube. It is only x minus 5.
No, it's not whole cube. It's I think a linear.
Yeah.
It's
It's
a
just
linear.
crossing the point.
Yeah.
So it's linear. So what will be the minimum possible degree now?
6.
Correct.
6.
6. Okay. So that is how you have to check at the behavior of the graph near the roots. Then you have to calculate the minimum possible degree. Okay. Okay.
But ma'am, in the class what they said, if polynomial is n degree, which is x power n, so then turning points, okay, maximum turning
The
points will be
maximum
n minus
possible
1.
number of turning
Okay,
points is
okay.
n. That means the number of turning points will be like the number of turning points cannot be more than 5 here. Okay?
Yeah, got it.
That
Got
means it can be anything from 0 to 5. Okay.
Yes.
Number of turning point can be anything from 0 to 5. Okay.
Yes, ma'am. Thank you.
So if you want to calculate the exact number of turning point of some polynomial, then you have to draw the graph. Okay. And then only you can calculate the exact number of turning point. But the maximum possible number of turning point will be degree minus 1. Okay.
Okay.
Ma'am, given a graph in an exam, if given a graph, they ask us to find out the maximum possible number of turning points. You have to first form the equation, find the degree.
No. If you have the graph,
Straight away you can find but you can find the actual turning points. But if they say find the maximum possible number of turning points, then we have to find.
If you have the graph, obviously they will not ask you for the maximum.
Maximum, okay. They will give only what is the actual turning points.
Only
Okay.
Yeah.
Fine.
So there is no meaning. If you can find the exact one, so why we will
Why
go
you
for
want to give a maximum?
approximation?
Right. Okay, understood.
So if you can find the exact one, no need to find them.
But if,
again,
hypothetically, if such a case is there, then we have to first form the equation and then find the degree, and then from that you minus 1 and you say that's the maximum number of turning points.
Yes.
Okay, right.
Okay. So one more thing is left, SSE. So SSE means we know that this is basically to calculate the approximate error between approximation of some equation and the exact value of some equation, right? So if I have some given fx and the chart with, so we will calculate the error. This is suppose y star. Error is y minus y star. That means exact approx minus exact value of y. Then we have to we will find some error ai. We have to square them. Then we have to sum them. This is nothing but our SSE. So we will just let us solve a example. Suppose we have f of x equals to some x squared plus 1, and we have x. Okay. Suppose this is the data given. We have the approximation f of x equals to x squared plus 1, and we have the data table. So we have to calculate the SSE. Just calculate and let me know what is the SSE here. So what will be the first error?
2.
F of 1 minus 3, right? right?
It is 1.
So 2
1.
minus 3 minus 1. 1 or minus 1, right? Okay. What is the error? 2?
Minus 1.
So it
Or
will be
1 plus 1.
One,
Yeah,
one plus
1.
1.
1.
Yeah.
f of 2 minus 4, right? So that means 5 minus 4.
It's
So
4. It's 1. Next is 2.
error 3.
2, ma'am. 10 minus 8.
Okay. What is error 4?
17 minus 19 is minus 2.
Okay. So what will be the SSE then?
Square of the errors under root, right?
This one, right?
Yeah.
So you have to square it, no? Sum of squares.
Sum of
Yeah.
square. So we
Sum.
have 1, 1, 2 minus 1. 1 minus 1, 2 minus 2. So if I do the square, it will be 1144, right?
Yes. And 4 square is 16.
Already we have done, like we did 2 square. Then we came.
Oh, okay. Okay.
These are the 4 errors. After doing the square, we can find this 1144. So this is the SSE. So this is the typical process to find the SSE. Okay, so these are some portion from week 1 to 4. Now it's up to you. Whatever doubt you have, we can now discuss from this portion.
Ma'am, this SSC, I guess this was there in the quiz 2, I think.
Quiz 1.
Quiz 1, sorry. Quiz 1. So will it, is there a chance for that same, similar type of question to come up in the final? Or I know you cannot say that, but still. I guess the probability is low for, I'm not, sorry, probably others may not.
You can guess whatever you want.
Okay. Because I know, I scored this mark in quiz 1. So repeating again in a final, when the probability is very, I'm not ruling out, but the probability is very, very low.
There may be some question using some concepts.
Yeah.
We can't say anything about it. Maybe, may not be also.
Yeah.
So it's better to recall things.
Recall, yeah.
Just recalls, yeah. Any other doubt, anything else, you can just ask.
Actually, to be very frank, just before the exam, I saw the video. I think one of your videos. I think you or someone else on this SSC, and I could recollect in the exam, or else I would have missed that question completely. In fact, just before going to the exam, I solved this and I made a mistake and I corrected it. So it really helped me in the exam that mistake I didn't do it, or else I would have ended up doing that same mistake, some calculation mistake.
Okay.
Yeah, I still recollect that.
SSC is nothing but just a calculation. So
Yeah.
nothing to take any hectic about it. You may be sometimes confused with this function and symmetric, reflexive. But if you just follow that simple logic, that the example, if you can construct example, which is contradicting the definition, that means it is not that definition. But if there is no example, means it will follow the definition. So this simple thing we have to just keep in our mind. So it is enough. Okay. Any doubt? Maybe something related to concept or any problem do you have? No? I'm waiting for some time. If you have some doubt, I did my side. Now, if you have some doubt, you can ask. Otherwise, you can leave. I will be there for 5 more minutes. If you have doubt, just ask.
Only 3 people are there, ma'am, completely.
Yeah.
The attendance is
less weightage means less number of people.
there are a number of people.
Okay.
Ma'am, just sort of a general question. I don't know, maybe others may have a question related, but it's out of. Ma'am, this especially the calculus portion, which is from week 5 till 8, I guess, which is so when I'm going through this Thomas calculus, right? What is that book? Is that what you refer normally?
Thomas calculus.
There's a book.
Yeah.
Is that because when I looked at that book, it's actually the chapters are exactly sequential as what is in the syllabus. So I was just thinking maybe is that the reference?
No, we have already given the references, right? If you have the reference given.
Yeah, book is there, but the reference is not this one, Thomas calculus, but Thomas calculus.
You can use any book.
One of the instructor was referring that. So when I went back and looked at the book, I thought of basically the course itself was built at least for those 4 weeks around that book.
Yeah, then obviously you can follow that book. So if you are finding it that the basic thing is you have to just solve multiple problems, right?
Correct.
So you can pick up any book and solve multiple problems to build your concepts. Okay? So any book is fine.
Okay.
Okay, so any other question?
No, not from me.
Okay, then maybe we can.
Okay, ma'am.
Yeah.
Okay, yeah, thank you.
Okay, yeah, good night.
Bye, ma'am.
Yeah, good night.
Good night.